Well, good afternoon, good evening, good morning, wherever you are tuning in from, and welcome to SETI Live. My name is Simon Steele. I'm the Director of Education and Outreach at the SETI Institute, and I am joined today by Seth Shostak, the Senior Astronomer at the SETI Institute. And we are going to talk about the results of a paper that Seth has published. The paper is called The Argument for Artifact Searches, published recently in the Journal of Astrobiology. And of course, with a title like that, we have to do a SETI Live about it, don't we? So maybe Seth disagrees. So it's great to speak to you, Seth. This is a fascinating paper and a fascinating discussion on the concept of alien artifacts. And I just want to, before we dive into artifacts themselves, maybe just sort of go back a little bit in time to talk about the traditional SETI searches that have been going on since the 1960s, started by Frank Drake, amongst others, of course. And we are now in 2020, almost 2021, and we have not discovered technosignatures, signatures from alien civilizations. Why do you think that is? And Seth, you're muted.
Yes. Well, I intended to mute myself for the next hour, simply to spare the audience. Why haven't we found anything? There are many possible explanations, of course. On the one hand, it could be that we are the only intelligent species in the galaxy. I find that a rather self-centered point of view. Probably not true. Let's hope it's not true. But the usual explanation is simply that we haven't looked at enough star systems. We've looked at, maybe a few tens of thousands of star systems, and that may not be enough. You just have to, if you're going to look for something, you can't give up when you've already only really scratched the surface of the sample that you might need. So that might be it. But in the context of today's discussion, here's another idea, and that is that when we do a search, a radio search like Frank Drake's back in 1960, we point these big antennas in the direction of some nearby star, hoping that there's somebody on a planet around that star who for some reason is broadcasting into space with that signal reaching us just at the time that we're listening. And that may be too optimistic a scenario. Maybe that signal reached us, 100 million years ago, and our SETI searches aren't going to pick it up. So it was that, that sort of disadvantage of traditional SETI that motivated this paper.
Yeah. And then there's two sorts of signatures you get when you're doing a radio search, of course. We've been, as humanity, have been broadcasting sort of isotropically into space for 40, 50 years. And this sphere of radio information is spreading out, but it's not very strong, is it? And so you can't actually detect that from very far away. What you really need is a sort of pointed, targeted transmission. But that suggests you need to know where you're going to aim at.
Yeah, exactly. I mean, people will ask, okay, you guys are looking for signals coming from ET, but are you looking for, just sort of this general noise that any high-tech civilization will make, and all the TV stations, all the FM radio stations, all the radars? Or are you looking for somebody who's deliberately pinging us? And, if you're looking just for general noise, that's really hard to find because that requires much more sensitivity than any of our searches today. I mean, you can work out, could you detect, for example, all the TV stations on Earth from even the nearest other star system, Alpha Centauri, using the best SETI equipment that we have now? And the answer is no, you couldn't. You actually couldn't. Now, with bigger antennas, you could, but not with the kind of equipment we have now. So if we're going to succeed, it's probably not going to be finding that kind of leakage radiation. You got to hope that they deliberately target us because they want to get in touch, or they've seen oxygen in our atmosphere, or they just have a lot of used cars they want to unload.
So on that note, and yeah, as petrol-driven cars are being sort of phased out in the next 20 years, we're hoping that there is a big market in elsewhere in the galaxy, perhaps. Thank you, everybody. I've got a list. Rebecca McDonald is typing frantically, telling us where people are listening in from. Berlin, Puerto Rico, Oklahoma, France, Utah, Vermont, Surrey in the UK, Monmouth in Wales, Canada, Estonia, New Zealand. Thank you very much. We'll keep in touch with who's who's listening from where. And if you do have any questions as well, please type those into Facebook, and those questions will be passed on, and we'll come to those in a little bit. So assuming that we're going to move on from traditional technosignature searches to looking for artifacts themselves, can you define what an alien artifact is? This isn't an Indiana Jones thing we're talking about, is it? This is something else.
Well, nobody actually knows what an alien artifact is. You can look in the movies, and they like to make giant monoliths, and apparently the aliens have done that in Utah recently. But anything that's out of the ordinary, anything that looks artificial. And the reason that it might pay to look for that, I'm not saying we get rid of traditional SETI, far from it, but I think that we ought to consider looking for these artifacts in maybe a little more energetically than we have done in the past. To begin with, they don't have to transmit in our direction. The second thing is the artifact might be there all the time. I like to liken it to saying, all right, if you wanted to find the pharaohs of Egypt, right, you could fly off to Cairo and look around, but you won't find any pharaohs. They're gone. But you could find the pyramids. The pharaohs have been gone for thousands of years, but the pyramids are still there, and presumably will be there for a little bit longer until air pollution destroys them all. So the point is that if they look for artifacts, you might just have a higher chance of finding something. What could they be? Well, I mean, they could be things like Dyson spheres or Dyson swarms. That's what we think of a lot when we think of artifacts. But it could just be anything that looks unusual. It's hard to find these things if you're looking at hundreds of light years distance, but there might be something. And there are some experiments today that are looking for things that change in the sky that don't look like nature. That's the bottom line. You look for something that's not nature.
So it's something that, as you say, we think we know what stars, how the structures of galaxies, nebulae are, and their natural phenomena, but you're looking for something a bit bizarre. I suppose that maybe leads us on to the subject of something that probably isn't an artifact, and that was the discovery of Boyajian's star. We now have an ability to detect planets around other stars, exoplanet searches, and we've now almost 5,000 planets around other stars that we discovered, and planets an understandable shape, and if they are moving to eclipse their star, they have a characteristic signature of what happens when a planet passes in front of a star. And how can this lead us to some ideas of how we could possibly search for artifacts?
Yes, this is a new project, as we know at the SETI Institute, because one of our own is involved. Anne-Marie Cody has gotten some money from NASA to do this kind of project. And they're just going to look essentially at data from the TESS Space Telescope and maybe even Kepler. But in any case, the data that shows how bright a star is as a function of time. So if you were to go out every day and look at the sun, not recommended, it's not good for you. But if you were to do that, you would see that the sun is essentially the same brightness every day. It varies a little bit because of big sunspots and that sort of thing. But those changes are very, very tiny. So the sun's light output is the same. But there are stars whose light output changes, and not because of a transiting planet, but for some other reason. Something might be getting in the way, a comet tail or something like that. Or it could be that the aliens are in that system and they built something big, really big, as Douglas Adams would say. So no, maybe it's Shatner who says that, William Shatner. Anyway, well, somebody says it. And so, if they built something really big, it might occasionally get in front of their stars seen from Earth, and we might discover it that way. If you can't find a natural explanation for this thing, then you have to say, well, Bob, I still don't know what it is, but it could be aliens.
So you've really got to rule out the natural, and that's not necessarily easy because there's still nature's still throwing wonderful things at us. An example being fast radio bursts that are these very, very rapid radio signals. Humans have been optimistic about radio signals for some time, and their origins that are not natural. Pulsars was one of them, and it turns out FRBs, fast radio bursts, is another one. They seem, how can nature make these weird and wonderful things? But nature has a way of making weird and wonderful things and confusing us. Dyson spheres you mentioned. Now that if we're going to find these things around other stars, these things have to be pretty big, don't they? You're not going to detect Elon Musk's Tesla anytime soon. So what's the limiting constraint of finding artifacts if you're looking around other stars?
Well, if you're just going to deliberately image them, maybe that'd be the way to find Mr. Musk's Tesla. Just take a big telescope and just look for it. But if you're talking about something the size of, something big, let's say something big, and it's hundreds of light years away, even our best telescopes are going to have a hard time seeing it directly. In fact, there's a little calculation in the paper, I think, where if something is 300 light years away, and I take that as a distance to the nearest aliens, because I figure that contains 1 million star systems. There are 1 million stellar systems within 300 light years. So if you say, okay, you need 1 million to find one alien inhabited planetary system, then they're 300 light years away. So what could we see with our best telescopes at 300 light years? Well, it'd have to be the size of the state of South Dakota for us to be able to see it, and also have to be bright enough. And maybe that's too big for the aliens to build, But is it really? I mean, we've had a technological civilization for hundreds of years, but the aliens may have had it for millions, conceivably billions of years. So don't sell them short. Maybe they really have built something very big.
Yeah. We got lots more listeners coming in here. Thank you very much. From Estonia, New Zealand, the Netherlands, South Devon in England, Ohio, somebody from the Bay Area. We've also had a donation. Scott, thank you very much for making a donation. You can make donations on Facebook. I just remind everybody that the SETI Institute is a non-profit organization. We rely on donations to keep us going. We get money from NASA contracts as well, and NASA grants, that's true. But a lot of our functioning happens from generous donations to viewers like you, to use a cliched expression. So thank you very much. It all helps. So we're not going to be able to send something, Seth, the size of North Dakota up into space for a little while. So that sounds as though we are, by definition, dealing with a more advanced civilization than we are. And as you say, it's difficult to know what other humans are thinking up, let alone an advanced civilization. There is a scale of civilizations, isn't there? It's called the Kardashev scale, and maybe you can say a little bit more about how you define the level of civilization, 1, 2, and 3, of which the humans represent the sort of the lower tier, as it were. Can you say a little bit more about this sort of this distinction, or how you pigeonhole civilizations?
Yes, the Kardashev scale, which was actually you could find it in his bathroom. The Kardashev scale actually was it was an invention of Nikolai Kardashev, who was this. Well, I think he's still alive. Maybe he's not. I better not say anything there. But
we'll see if he writes in. He might have something to say about that.
You didn't mention Moscow in the list of people or the list of locations. Anyhow, he just said, look, basically there must. You could say there are 3 conceivable types of civilizations based on their energy use, right? So a type 1 civilization, the lowest of the low, uses the energy reserves of their own planet. Now think of humanity. We're using the energy reserves of our planet. And, whether that's the wind power, the solar power, well, solar power is maybe not the energy of the planet, but certainly all fossil fuel use. That's the energy of your planet. Type 2 civilization uses the energy of its star. So if we built a giant swarm of solar collectors, a kind of Dyson swarm, out beyond the orbit of Earth to collect energy, well, then we would become a kind of a type 2 civilization, where we're using much of the energy produced by the sun. A type 3 civilization uses the energy produced by its entire galaxy. Now, look, the whole point about artifact searches is you forget about looking at the nearest other star system that might have a planet sort of like the Earth. That's old think. See, new think is to say, look, the universe is very old. It's 13 billion years old. So there are some societies out there, presumably, that are incredibly farther along than we are from a technological perspective, right? Maybe 80%, 90% of them blow themselves up or get bored with television or for some reason go away. But that still leaves some. So the idea is, instead of trying to find a society that's, sort of like ours, maybe 100 years more advanced, maybe 1,000 years more advanced, go look for the really old guys, right?
Mm.
That kind of leads me to a joke that all right. So you go look for the oldest civilizations.
Hmm.
They may be building the biggest things. And
Hmm.
so, that's another thing about artifacts.
Yeah, there's a little bit of a time constraint, isn't there? I mean, the human civilization is based on a 4 billion year old, 5 billion year old star, and evolution that's happened for 4 billion years. So if there are a lot of stars are younger than that, but there are a lot of stars older. Um, uh, and a lot can happen in a million years of evolution, which is a very small part compared to 4 billion. So really, you're thinking about targeting older stars. So you need to think about, look at the star system and figure out how old the star is. Do you think red dwarfs, which tend to be around for a very long time, are they a good place to look?
Well, I think so. I'm partial to red dwarfs, and it was also a British TV show, I believe.
It was.
There you go. Yeah, red dwarfs. You're right. Red dwarfs live for at least 10 times as long as a star like the sun will live. So every red dwarf that was ever born in our galaxy is still out there now, enjoying its youth. And as soon as the pandemic eases a bit, those stars will be able to go to the local bars and just enjoy life. So those stars have been around for such a long time, and there's so many of them, right? Something like 9 out of 10 stars is a red dwarf. That maybe indeed that's where ET is hanging out. Now you can say, I don't want to live around a red dwarf because it's so dim, right? It's trouble enough to live in a neighborhood where everybody's kind of dim, but to live around a red dwarf, you might think, I'm not going to get enough energy to grow my crops and so forth and so on. Those are all very provincial concerns. You can do all that. They're still putting out energy. You can live around a red dwarf. So yeah, let's look around red dwarfs.
Okay. I was thinking maybe some more examples. We talked about Dyson spheres. I've got a ring world behind me in this illustration that I nabbed from the web. So unfortunately, I can't offer to sell it to people because it's somebody else's. But what other examples have you got of say a type 2 civilizations, one that can build Dyson spheres, or even type 1s? What other things could we potentially be looking for?
Yeah, well, it's hard. You've already mentioned this, Simon. I'm not trying to duck the question, but it is hard because if you had asked this, if we were having this discussion 110 years ago, say in 1900, right? People were talking about the canals on Mars, and most people thought there were canals on Mars, right? Today that seems kind of quaint, but if you ask, even astronomers, what would an advanced society do? They'd say, well, they'd build a lot of canals, right? Yeah. So the idea of being able to predict what really advanced societies would do is quite difficult. Yeah. But the Dyson spheres is certainly one possibility. Dyson swarms, whatever, these very big structures to collect a lot of energy. Mm-hmm. Now, there's a fellow here in the Bay Area by the name of Gerald Nordley, who also writes science fiction. He's a very clever guy, and he gave a talk 2 years ago, I think, in which he pointed out if you did build a Dyson swarm or a Dyson sphere, not only would you have all the energy you could possibly eat. I mean, that's a lot of energy you could collect with something like that. But you'd also have a really big baseline. In other words, it's a long way from the one side of the Dyson sphere to the other, right? It might be a couple of 100 million miles. That's the dimensions of these things. So you have all this energy and you have all this real estate, and that means you could build transmitters to convert that energy into whatever, microwaves, infrared, something. And you could easily take out, a planet hundreds of light years away if that was on your agenda. So he was suggesting that actually Dyson spheres are probably illegal. Whatever that means in the galactic context.
Yeah. I'm just going to ask one more question, then we'll get a lot of questions coming in. Dyson spheres, circumstellar disks or rings, these are all constructions that would result in an unplanned detection. Nobody's going to build a Dyson sphere to be recognized. If you wanted to have a deliberate "we are here" moment for an advanced alien civilization, what sort of thing? Again, we're projecting 21st century human brains into what an advanced civilization would do. What do you think we would be looking for? Something that would be deliberately recognizable that, maybe is passive.
Yeah, well, if you want something that will forever mark your existence, like a tombstone, I mean, that sounds a little lugubrious, but you know what I mean. And all you want to do is tell whoever is out there, somebody is here. This is a monument. It's like a cairn, right? Stack of stones. Somebody was here in this part of Antarctica. You could just build a big obscure, just a big sheet of metal, very thin metal, so you could eventually construct it in space and have it orbit your own star, and then have another one orbiting in the other direction. And anybody looking at the sun would suddenly see it get very much dimmer and then go back up, and then get dimmer and then, brighten again on a very regular basis. And with some very simple geometry, you could convince yourself this is not a planet doing this. This is something else. And so that would mark your stellar system if you do that and are not afraid of the Klingons.
Okay, we're going to turn our attention to some of the questions that are coming in. We also have another donation. Massimos, thank you so much for your donation. Now, this is a question actually close to home. This is something I was interested in. If a robotic system or an alien civilization passed through, would they leave something behind? We've all seen 2001. There's a good thing to stick on the moon. And one of the questions is, how difficult or expensive would it be to do a search for artifacts on the lunar surface? And how would you even go about knowing if something was an artifact or natural?
Well, once again, this sounds like a Stanley Kubrick movie. But in fact, I mean, you could say that the moon is better mapped than, the bottom of the oceans here on planet Earth, because we do have orbiters orbiting the moon, and they do make photos. And I've forgotten the best resolution. In other words, how much detail can they see? But they could see something the size of a small house for sure, and maybe, the size of a school bus. You have to look it up. So you could say, all right, there are all these images. Well, who's going to sit there and look at these tens, hundreds of thousands of detailed photos of the moon and say, oh, look at that? You could make it a citizen science project. People are forever looking at the photos made by the rovers on Mars looking for signs of life. But you could do it that way. But today you would just have, artificial intelligence, machine learning, really, and just scan all these things. And I'm sure 10 years, 20 years from now, we'll have orbiters around the moon that'll be able to see something on the scale of what you can see with Google Earth. So if there's anything that's that big and that is recently enough put there so that the rain of micrometeors hasn't wiped it out, then maybe we'll find it, if you think the aliens have been to the moon.
Maybe Utah. I don't know if you want to comment. There's a question about the monolith that somebody's found in Utah just now. Maybe the same people who did the crop circles in Wiltshire. I don't know, but or maybe we don't even want to go there.
What Wiltshire? Yeah, some of the crop circles are either in Wiltshire or Hampshire. With the rest of the UK, but somehow, yeah. Well, this monolith in Utah, it may be that somebody's expecting a whole bunch of primates to go to Utah and sort of rally around this thing. I figured it was a Wi-Fi hotspot for the aliens, but I think that your assumption is probably the correct one, Simon. That this is a bit of art.
Yes,
and very imaginative.
There was coming close to home. There was not that close, but there was an interstellar visitor. There's been a couple now. Well, the first one was called Oumuamua, which had the impression, it was probably an asteroid that had been flung out of another star system. It passed by the Earth or passed by the solar system and flew out again. I know it was studied in reasonable detail, and I believe that Greenbank did an analysis to see if it was transmitting. So that there are possibilities, I suppose. We don't know what alien civilizations are doing or how they're influencing or want to, influence us or make themselves apparent. So a little bit about Oumuamua. What's your feeling on that and that as a technique to come and visit in a sort of stealthy way?
Yeah, I think Arthur C. Clarke wrote a story, right?
Mm-hmm.
Was it Charles? Yeah, I know. Yeah,
Rendezvous with Rama. Yes, yes, a good book. Yeah.
they all, after a while, there's just a literary blur. But indeed, the aliens might have hollowed out an asteroid, put an engine on the back, and used it as a vehicle to come visit our solar system. Now, the problem with the Oumuamua, by the way, that idea was seriously suggested by the chair of the Harvard Astronomy Department, Avi Loeb, and he pointed out that unless there are a lot of these things, I mean, you can say it's an interstellar asteroid because it came from outside our solar system. But unless you assume there are just lots and lots of them, you can't argue that, yeah, this is just an interstellar asteroid that just by chance happened to zip through our solar system, coming right into nearly the center of the solar system, the sun, and then on its way out. I mean, that's terrific targeting for a random process. But it turns out that another one was found a year and a half later. So probably it was an asteroid. But this thing was so far away, we never saw it as anything more than a dot. And some people say, well, why don't we launch a rocket and go look at it up close? Maybe you'll see portholes with little green faces behind them. Maybe, but we didn't have the rocket technology to do that. But if you know in advance, if you have more warning for the next one, then maybe we will do that.
Yeah, I have a question here from a writing question from Tara in Woking. Could aliens communicate with us by sending comets and asteroids to Earth? How would we look for clues much closer to home?
Yeah, well, it's the same problem. If it's close enough that you can actually get a good picture of it, say a Oumuamua, it was always a dot, right? Everybody saw that artist impression. It looks like a kind of a bumpy cigar, but that was an artist impression. That wasn't a real photo. But if it's close enough, Tara, then you could, of course, see. But there are other things. If it's got a bit of a tail or develops a tail when it gets near the sun, then you can say, okay, it's probably a comet and so forth. We probably could recognize the colors. That's another thing. We could probably recognize whether it's an asteroid or a comet. As a method of communication, I don't know. I mean, you could do it, but why? You might as well build a rocket, right? I mean, rockets don't have all that stone you have to carry around.
And of course, what's interesting is the OsirisRex mission is returning a piece of cometary material, a piece of asteroid material rather, from Bennu, and that will be in a couple of years' time. And so we'll have a better idea of what asteroids are made of by sampling that material. In a sense, I know this is, the various ways of thinking about life emerging on Earth. One of the big possibilities is that some of the organics were delivered to our rock in this process very early on in the solar system. So, that's a sort of message.
Well, that's a good astrobiology project. Yeah. But there are people who have suggested that if you're a really advanced society and you want to spread your species around, it sounds like a well-known sci-fi film, but if you want to spread your species around, the thing to do is rather than, jumping into their tummies and exploding out and all that kind of thing, that's really difficult, that you just put genetic material or whatever is your genetic material, might not be DNA, of course, and you just put it in rocks that go from one solar system to the other and occasionally hit something and, infect that world with your species. This has certainly been used by Hollywood, and, it might happen. But, the problem I have with that is that, again, it's assuming the aliens are biological. And I think advanced aliens might much more likely be machine intelligence. But, maybe they just put some little self-replicating machine into a whole bunch of comets and send them out there. And wherever they land, they reproduce and build something, impressive, like the city of Akron, Ohio.
Here's another question about new ways. We talked about radio astronomy, and that has been the fundamental way to detect technosignatures. And maybe this is a good time to to talk about the laser SETI project at the SETI Institute. How are new kinds of astronomy being used, and how could they potentially be used for artifact searches?
Well, I think that there's hope here. I mean, really there is. You mentioned laser SETI, and that's a project of the SETI Institute, as well as the University of California, Berkeley, and others. And the idea is instead of looking for radio waves, you look for flashing laser lights. Now, that has the same problem that I think the radio searches does. In other words, that either they're aiming their lasers at you for some reason, and if they're far away, they don't know Homo sapiens is here because they haven't picked up our radar TV. So, it doesn't make sense for them to deliberately target us. But maybe there's just a bright flashing light, like the kind you see on, the wings of aircraft, just to say, I'm here, don't hit me, kind of thing. That could be, but it has the same energy problems. The amount of energy required to make a light that you could see from far away is considerable. Nonetheless, it's certainly worth looking for these sorts of things. Absolutely.
Mm-hmm, mm-hmm. There's a long question here, and I'll just sort of paraphrase. There have been, obviously there's a lot of data coming in from telescopes all over the world. There have been some false detections, false alarms for SETI detections. Are there any sort of things that, still stick in your mind that you could have said, well, maybe?
Yeah. I do get asked that question. You have a drawer full of, well, these are pretty interesting here, Bob. Hey, well, in the old days, you used to get a lot of, we're not sure what it was because you would only see it once. And by the time you looked at the data, that was, you took the data a week, a month, a year ago, and now you say, oh, there's something here. But you're not at the instrument anymore. You're not at the telescope, so you can't kind of follow up. Now, these days, the kind of experiments that are done at the SETI Institute, in any case, you follow up right away. You find something interesting, you don't sit around and debate whether you should follow up. The machine automatically does that within a minute or two. So, that's okay. But in terms of have we ever found something, well, people will say, are you close? Right?
Mm-hmm.
That kind of question. You can't say whether you're close. Mm-hmm. Either you found it or you haven't. It's a one-bit experiment. It's 0, 0, 0, and then it might be 1. And I usually say, and this is, of course, probably unacceptable, but it's like pregnancy, right? Are you close? That doesn't mean anything. Either you are or you aren't. And it's the same thing here. Until we find a signal, all we can say is that we haven't. People ask about the wow signal. That's certainly intriguing, but it was only seen once. And until you see it twice, you can't say that you found it.
Yeah. Yeah, it's just that's how science has to work. You need that verifiable observation and independent verification, and that has not happened yet, unless there's one of those files in your cabinet that has a very big padlock on it. I must say, but anyway,
if I had that, we could be sitting here talking with you. I mean, I would open that up and just book a ticket to Sweden and collect the Nobel Prize.
Yes, and that brings me to one last question from the audience, and that is the process of announcing a discovery. And this, obviously, as we've just said, you can't just detect a signal one night and then go out and make an announcement. There's a process there, and what sort of process would we need to go through?
Well, there is an official protocol, but it's not terribly helpful because it simply says, check it out and tell everybody and, don't broadcast anything back until you talk to other countries or whatever, that kind of thing. Those protocols do exist, but they're just sort of like signing the pledge on your exam book, on your blue book, I will not cheat, right? I mean, it might help, probably does help, but it doesn't guarantee that you didn't cheat. So what really happens, and I know people have a hard time believing this, but what really happens is if you find a signal that looks good, immediately the media, the local TV stations or radio stations, the newspapers, the bloggers, everybody starts getting in touch with you because there's no policy of secrecy. So everybody is, messaging all their friends, hey, we got something interesting here, even though it might turn out to be nothing a day later. So the way it will be dealt with is that it will simply be a big story. And then everybody in the world who has a telescope, right, will start looking in this direction. You can be sure of that.
Yeah. Well, thank you very much. I see another donation. Steve, thank you very much, Steve. Wherever you are, that's wonderful. So Seth, if we gave you quite a large budget and not much limitation on real technology, what would you build to leave a legacy, a visible legacy for humanity?
Yeah. Oh, you mean something that the
Yeah,
aliens
something big, something big. Yeah.
got to be big. Well, I mean, certainly the obvious thing, putting a lot of power sats into orbit that's been talked about for at least 30 or 40 years. And keep in mind that it has the advantage, not only can the energy be inexpensive, because to make another kilowatt hour of energy doesn't cost any more than the last kilowatt hour. You don't have to burn anything, you just collect sunlight. And of course, it produces no pollutants to the atmosphere. And you might say, well, why aren't we doing that today instead of windmills or natural gas or all the things that are kind of alternatives to the usual fuels? It's the capital cost. It's just a matter of economics. Mm-hmm. But what I would build I suppose I would make a recording of the entire internet and put it on some sort of medium that could withstand the cosmos for 1 billion years. And maybe that's just chiseling it into stone or something. I don't know. But the entire internet, and shoot it into space, and it doesn't matter where it is, and put a lot of radar reflectors all over the thing so somebody will find it.
Mm-hmm. And that certainly will persuade aliens not to come and visit this planet, I've got a feeling.
Well, they'll come, but they'll want to visit the cats.
Yeah. Seth, thank you very much for the conversation. Thank you, everybody, for tuning in, watching, listening. It's wonderful. We'll be back again soon. Please keep an eye out on our Facebook page. This was recorded and you can watch it at your leisure on YouTube as well, the SETI Institute YouTube page. And we will speak to everybody